find the length of a line, we need the x and y values of both points. Since we have those, we just need to insert them into the length formula, at which square root x1 minus x2 squared plus y1 minus y2 squared. When doing this step, be sure to follow the same order of values like -6, -2 and 10, 2. The 2 is the y2 and the -2 is the y1. Same goes for the x, at which 10 is x2 and the -6 is x1. Once we simplify this, we should be able to get the answer, and we should repeat it for all three lines: line xy, yz, and xz.
Okay, so for question B, we have to find out whether the triangle XYZ is a right angle triangle or not. So according to the Pythagoras theorem, if the triangle is a right angle, a squared plus b squared is supposed to be c squared. So c squared is the hypotenuse and a and b are the other two sides. So in our case, the hypotenuse is xy, the side xy. So the value for xy, we have it from part A is 16.5. So we take the square of 16.5. That is 272.25. So now we have to square the other two sides and add them up. So we have yz squared plus xz squared. Those are the two sides. So the value for that is 270.89. So we see the values are different. So 272.25 and 270.89, those are two different numbers. So since it's not equal, this triangle is not a right angle triangle.
So for question C, we need to find the area of the triangle. So we use the formula, which is half length base times height. We substitute in the value of the height, which we got in question C, which is 7.69 centimeters. And by substituting in the value that we got for xy from part A, you can get the answer, which is 63.43 SF. For question D, we use the sine rule, which is sine A over A is equal to sine B over B. And we substitute in the values of sine A, sine B, A and B, which is sine 69 over 14.142 is equal to sine YXZ over 8.4852. By simplifying the equation, we can find out that YXZ is equal to 34.1 rounded off to 3 SF.
34.1 degrees.
Degrees? Bro, it's